Hi learners, welcome back to DHILK. In this video, we are going to practice IUPAC naming with some important examples. In the previous classes, we have already covered the complete step-by-step rules for naming organic compounds, both with and without functional groups and through IUPAC naming system and common naming system. So if you haven't watched those yet, make sure to go back and check them first because they will help you to understand today's problems much better. So today's session is all about applying those concepts. We will solve examples one by one with clear explanation so you can build a strong and confident understanding of IUPAC naming. So if you didn't watch the previous videos, just click the icon, then make sure you don't skip any part because every step matters in getting the correct name. So alright, let's get started with our first example. So let us just recap the methods or step-by-step pathways that we have to follow while naming. So with and without functional groups we are mixing here. So if functional group is present, then what we have to do first, we have to spot all the functional groups and we have to rank by priority. Then by spotting the highest priority group, we will assign the highest priority functional group with suffix, the rest will go to prefix. Then if once we analyze this, then we can move to find the longest chain. So if no functional group is there, then we can start from this step. We have to find the longest chain including the principal group. Then nextly we have to search for the unsaturations. If there are any unsaturation, double bond or triple bonds, then we have to number the chain, then alphabetical prefixes, then assemble all these things into the general formula: prefix plus root plus primary suffix plus secondary suffix. Make sure that you are okay with these concepts. Okay. Now we can start to do problems. In this video we will try to solve 4 problems. Each of these problems will give you different ideas. Okay. We are applying these concepts, whatever we had learned from the previous videos. We can start with the first one. So we can check for the possibilities of the chains. So totally how many possibilities are there? Either this chain can be the parent chain, or we can consider there is another possibility that this chain can be the parent chain, or this way this chain can also be another possibility. So there are multiple possibilities of chains, parent chains, but from this we have to choose the chain with the maximum number of carbon atoms. So if we are considering this way, how many carbon atoms are there? 1 2 3 4 5 6 carbon atoms. If you are selecting this way, we can have 6 carbon atoms. And if you are choosing this chain, how many carbon atoms are possible? 1 2 3 4 5 6 7 carbon atoms are possible in this way. Okay. And if you are choosing this way, how many carbon atoms are possible? 1 2 3 4 5 6. How many? 6. Among which we can identify that this is the longest chain. So we can choose this chain as a parent chain. Okay. Now we can remove all other possibilities and we choose this chain as the parent chain. How many carbon atoms are total? 7 carbon atoms. So we finished our first step. What is the first step? Identify the longest chain. We have to identify the longest chain. So that part is done. Now second step is that we have to number the chain. Okay. Numbering of the chain. So there are some rules to number the chain, right? We have discussed those rules. So here we can number from left to right also. We can number these compounds from left to right and from right to left. And we have to choose the numbering in which that numbering will give the lowest locants possibilities to the substituents. Okay, so 2 substituents are there. This group, this CH3 group and CH2, CH3 groups are substituents. So we have to choose the numbering which will give lowest numbers to the substituents. Okay, we can check the numberings from left to right and right to left. Okay, if we are numbering from left to right, what are the numbers that will get for these substituents? This is 1 2 3 4 5 6 7. So this CH3 group, the one substituent will get 3rd position and the other one will get 4th position. So instead of that, if you are numbering from right to left, what are the numbering possible numbers? It can be from 1, 2, 3, 4, 5. Numbering will be 4 and 5. So among these we have to choose 3, 4 because left to right numbering gives lowest numbers to the substituents. Okay, so we have to choose this numbering left to right. Clear? Next is that what is our general structure? Our general formula is that prefix plus word root plus suffixes, right? So here what is the prefix? Substituents. How many substituents are there? 2 substituents, the methyl group and one ethyl group, right? So we have to give numbers to these substituents, and for these substituents methyl and ethyl groups, the methyl group is at which position? 3rd position, and ethyl group is at 4th position. So by looking at this number we may think that we have to select this methyl, we have to write the methyl at the beginning, but whenever there are 2 substituents coming together, we have to choose a substituent based on the alphabetical order. Okay, alphabetical order we have to give the preferences. So by this alphabetical order preferences, which one will come first? Ethyl will come first. Okay, ethyl will come first. Now we can start to write our compound's name. And ethyl, which position it comes? 4th position. So 4, and we have to separate the numbers from the words using this bar. So 4 ethyl. Then what is the next substituent? Methyl. So for methyl we have to write the position also. At which position it is coming? 3rd position. So 4 ethyl, 3 methyl. So this is the 4 ethyl and 3 methyl. So this is a prefix. Now prefix is done. Now what is next? Next one is word root. What is word root? The number of carbon atoms. How many carbon atoms are there? 7 carbon atoms are there. So for 7 carbon atoms, the word root is hept. Okay, word root is hept. Now last one is suffix. What is suffix? Here for hydrocarbons the suffix is an. Okay, so finally what is the formula? For ethyl, then 3 separate by bar numbers and letters, 3 methyl heptane. So there should not be any gap between heptane and 3 methyl. Okay, clear? Now we can move to the second question. What is the first thing that we have to do? We have to identify the parent chain. So we can take either this way as the parent chain. How many carbon atoms will be there? 1, 2, 3, 4, 5. And there is another possibility is that we can take like this, right? So if we take like this, what will be the number of carbon atoms? 1, 2, 3, 4, 5, 6. So we can discard this way. This is not the parent chain, so it can be the parent chain. And is there any other possibilities? 1, 2, 3, 4. See, there is one ethyl group attached to this carbon atom, so we can check in that way. Is it possible or not? So if we take this way, how many carbon atoms will be there? 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms will be there, right? So this is the parent chain. So which is our parent chain? This is our parent chain. Okay. Now we can check for the numbering. From which side we have to number? From this side to this or this side to this? So if you start from here, 1, 2, 3, this way, this group, we can check the positions. Firstly, if you are numbering from left to right, then secondly we can check for right to left. Okay. So firstly, if you are checking from left to right, we can start from here. 1, 2, 3. At 3rd position, there are 2 methyl groups. So 3rd position, 3, 3. What is the other substituent? This one. This is at 1, 2, 3, 4th position. So 3, 3, then 4. 3, 3, 4. Then which is the next one? There is another substituent at 5th position, right? 5th position. So totally this will be the positions. But if instead of that, if you are starting from right to left, what will be the positions? 1, 2, 3. At 3rd position there is a carbon atom, 3rd position. Then at 4th position there is another carbon atom. So the 4th position there is another substituent. Then 1, 2, 3, 4, 5. At 5th position 2 substitute. So from these two we can choose the first one, right? Now we can choose left to right. So we finished the first one, we found a long chain. Secondly, we had to identify the numbering, that's also finished. Thirdly, we had to choose the positions of the substituents, we selected that one also. The 4th one is that we had to identify the word root. Prefixes are ready, right? Now we have to identify the word root. What is the word root? How many carbon atoms are there? Are totally 7 carbon atoms. So what will be the word root? It will be hept. So what is the final name? There is no functional group and there is no unsaturation. Unsaturation means double bond or triple bond. So the suffix will be ane. And we know what is our general formula. Our general formula is that prefix plus word root plus suffix. So we can start from the prefix. What are the prefixes? All the substituents are methyl groups. So we can write 3, 4, 5, tetra. There are 4 substituents. So tetra. You have to know this. We had discussed earlier also. Then also we can just discuss. If there are 2 substituents, same substituents, then we can use di. For 3 same substituent, we can use tri. If there are 4 substituents, then we can use tetra. Okay, tetra. Now here the name will be 3345 tetra methyl. This is our prefix. Then what is the word root? Hept, and suffix is ane. So 3 tetramethyl heptane. Okay, heptane. Now we can do this problem. So here whatever first step, first we had to identify the parent chain. Okay, so here it is very important, and you can see here there are multiple possibilities. So here if you are taking this way, how many carbon atoms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon atoms. And if you are taking this way also, both are same, right? This is H2 CH3 and CH2 CH3, both are same, so there is no complication here. But if you are taking this way, you can see how many carbon atoms will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon atoms. So in this way also, there are 10 carbon atoms. How many carbon atoms? 10 carbon atoms. So we are confused which one we had to choose. So basically what we used to do, we had to, based on the substituents position, we choose the main chain, right? But here you can see the substituents are different. If you are choosing this way, the substituents, there are one substituent at this position and one substituent at this position. But if you choose this way, how many substituents will be there? 1, 2, 3 substituents. There are 3 substituents. So one thing that you can get from this is, if there are 2 identical chains, then you have to select the chain which has more number of substituents. So these 2 chains are identical chains, right? So among these 2 chains, you have to choose the chain which has more number of substituents. So this chain, this way, if you are taking the chain in this way, it has the more number of substituents. So you have to select this chain. Okay. Now next step, the first step is finished. Now next step is numbering. So we can start from here also, But if you are starting from this way, you will get the lowest number to the substituent. So we have to start from this side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 carbon atoms. Now substituents are present at 3rd position. How many substituents are there? Now we can check the numbering. for the prefix. We can check for the prefixes. How many substituents are in third position? There are 2 methyl groups. So 3,3-dimethyl. Okay, dimethyl. And there is another substituent at 5th position, right? Okay, here one thing that comes is that at 5th position we have one substituent. Okay, now we have to number this substituent separately because this substituent has one more substituent, right? This is a substituent of this parent chain, and this substituent, it has substituent at this carbon. Okay, so we have to number this carbon also. So what will be the numbering? We can start from this side or this side, but here let us start from here, then only this carbon atom substituent will get the lowest number. So we can number 1, 2, 3, 4. So what is the name of that substituent? At 5th position, listen carefully, at 5th position there is a substituent. What is the substituent? You have to write in the bracket. I will mention why we are writing in the bracket. At 5th position you have a substituent. What is that substituent? That is 2-ethyl. What is this ethyl group? This ethyl group, 2-ethyl butyl. Okay, 2-ethyl butyl and 2-ethyl butyl. So we got the name for this 2 substituents. Okay, from this, which one we will select to write at the first? So we have to choose one according to the alphabet. So this one ethyl will come first, right? So what will be the name then? 5 2-ethyl butyl. The other substituent is 3,3-dimethyl. 3,3-dimethyl. What is the word root? Decane, right? There are 10 carbon atom and the suffix is ane. So decane. So what is our name? 5-2-ethyl butyl 3,3-dimethyl decane. This is the final name. So don't be confused if there are 2 parent chains but with different number of substituents, then you have to select this parent chain which will give multiple substituents. Okay, clear? Okay, now we can solve this problem, the final problem. So here, firstly we have to select the parent chain. Select the parent chain. So parent chain. So which is the parent chain here? You can start from here 1, 2, 3, 4, 5, 6, 7, 8. There are 8 carbon atoms. So it can be a possibility, and if you go this way 1, 2, 3, 4, 5, 6, 7 only, so that's not possible. And you can go this way or this way or this way, both are same. So finally we can choose this one, right? So this will be the parent chain. We finalize our parent chain. Now second thing that we have to do is that numbering, right? Numbering of the chain. Now how will we number? 1, 2, 3, 4. So if you start from this side, the substituent will get 4, 5, 6, 6. But if you start from this side, what will be the positions? 1, we can start 1, 2, 3. So the positions will be 3, 3, 4, 5. So we can choose this one, right? It will give the lowest position. Okay, so we can choose this positioning. Now what is our third thing that we have to do? We have to finalize our prefix naming. We have to finalize our prefix. So we can start to finalize. Now we can write the substituents. Which are the substituents? Firstly, at third position, 1, 2, 3. Third position, there are 2 ethyl groups. So we can write 3, 3. If there are 2 substituents, same substituent, then we can write 3, 3 di, right? Diethyl. So 3, 3 diethyl. Then what is the second substituent? At fourth position there is a methyl group. So 4 methyl. So what is the third substituent? At third substituent 1, 2, 3, 4, 5. Fifth position there is a substituent. What is that substituent? At fifth position there is a CH3 group. What is this? We had learned in the previous class that if CH3 group comes, if to a carbon atom there is a two terminal CH3 groups, then that is known as isopropyl, right? Isopropyl. So this at the fifth position there is a isopropyl group. Okay, now we got the three substituents. What is the next step? We have to arrange them in the alphabetical order. So while we consider in the alphabetical order this di and tri terms, di, tri, these terms we should not consider for alphabetical consideration. So here what is the alphabet? It is E. So in this case it is M. The first letter is M. So here I, so we have to consider this is I. So if we consider the alphabetical order, E is coming first, right? So it will, we have to write this substituent first, then I, this substituent second, then this one at third position. Okay. So now finally what will be our compound? We can write the compound name 3,3-diethyl, 3,3-diethyl, then 5-isopropyl, 5-isopropyl, then 4-methyl, 4-methyl. These are the substituents. Now we have to write our word root, right? Prefix is over. Now we have to write our word root. What is the word root? How many carbon atoms are there? 8 carbon atoms. So for 8 carbon atom, what is the word root? It is oct, and the suffix is ane. So octane, right? Octane. So this is our final name: 3,3-dimethyl, 5-isopropyl, 4-methyl octane. Okay. So this is about the numbering of the different. So we had learned different terms, so different points from 4 of these compounds. Okay. That's all about this today's session. So if you feel any doubt, you can just comment below, or you can reach out to me through this social media. So thank you for listening. So make sure rewatch this video if needed, practice the concepts, get fully comfortable before moving on. Then if you are a class 11 or 12 NCERT student and want complete materials, notes, tapes, tricks or live classes, one-on-one sessions, visit our website or contact us through the number. Check the description box or comment section for more details. If you found this helpful, don't forget to like, share and subscribe and turn on the notification bell. Thank you for watching. See you in the next video.